Hello everyone, welcome to my channel MathMantis. In this video, we are going to discuss an interesting problem of definite integral. We are going to evaluate the definite integral of greatest integer function and a fractional part function. And we will see how easily we can evaluate this particular ratio. This is the particular question. So to start with this question, what I will do is I will start with the definite integral of the fractional part function. To evaluate the definite integral of fractional part function, I will use its graph. As you already know, the fractional part function graph is periodic with period 1. This is the graph of fractional part function. We already know the fractional part x is nothing but x when the value of x is between 0 to 1. After that, the fractional part x is nothing but x minus 1 when the value is of x is between 1 to 2. Then the fractional part x value is x minus 2. Then it is x minus 3 and so on. This is you must be already knowing. Now what we will do is we will use the periodic property of fractional part function to evaluate this integration in a faster way. So what we will do is we will define the integration 0 to 1 of the fractional part x dx. As you already know, the integration defines the area with the x-axis. So what I can do is I can define this area as 0 to 1 integration. 0 to 1 tak we will define this integration as this particular area, that is the area of this particular triangle. If you will find the area of this particular triangle, this is nothing but base multiplied by height multiplied by half. That is the area of the triangle. So the area of this triangle is nothing but half 1 multiplied by 1. So this is the area of 0 to 1, that is of fractional part x dx. This is the integral value. So if suppose we have to evaluate the integration from 0 to 2 fractional part x dx, what we will do is it will be included, that is of two triangles, because the area will be now evaluated with x-axis. It will include two triangles area. So it will become nothing but this 2 multiplied by half. This will be the area, or this will be the value of this definite integral. Now suppose we have to evaluate 0 to 3. So this will become 3 multiplied by half, because it will include three triangles 0 to 3. So using this observation and logic, we can directly say that this is the value 2023. So if you will include zeros to 2023, the area will become, or this definite integral value will become 2023 multiplied by half. So we can directly evaluate this value in this particular way using the periodic property of the definite integral. And this is also the property you study in definite integral, that if it is a function given, if it is the function periodic with, that is period t, and the integration is from 0 to n, n is a natural number and t is the period of the function, you can write the integration as n multiplied by 0 to capital T fx dx. We can easily write in this way. The same property I have applied here. We can use this property also without using the graph to evaluate this integration. So what I can do is I know the fractional part x is periodic with period 1. So I can see here is the natural number 2023. I can bring this 2023 in front of the integration using this property, and I can write it as 0 to 1 fractional part x dx integration. And we already know fractional part x is nothing but x when x is between 0 to 1. So we can write it as 2023 integration 0 to 1 x dx integration. So that is nothing but x square by 2, and if you will apply lower and upper limit 0 to 1, this value will evaluate to be 1 by 2. So the answer will become 2023 multiplied by half. We can easily understand this value from the graph, and we can also use the definite integral property to evaluate this value. So this is how we can evaluate this function. So this is the clear part. Now we will come back to this part. But before this, let me generalize the result for fractional part function. Fractional part function, if the lower limit is a, upper limit is b, we can write the fractional part x dx integration as b minus a multiplied by half. But the condition is b minus a must be a natural number. That can be understood from the graph of the fractional part function. Suppose the value is from half to, that is 2.5. So what we can do is if we have to evaluate this integration half to 2.5, so what we'll do is we will evaluate this area. This is the particular area from half to 2.5, this area, this triangle area, and this area. So this will be the total value. But as you can see, this area will complement this area. So this area when combined with this area, that will be nothing but the area of the complete triangle. So if the difference between two lower and upper limits is a natural number that will be something like natural number multiplied by the triangle, because that many triangles will cover that area. So this is the result which you can directly use in the questions. Now we will evaluate the greatest integer function integral. To evaluate the greatest integer functional integral, let me give you a thought process which you can keep in your mind. The thought process is, if the greatest integer function integral you have to evaluate in a definite integral, and if that function is a linear function polynomial, so what you can do is you can directly solve it by changing it to fractional part function. It should be a linear polynomial. It can be directly changed to fractional part and it can be easily solved in that way. This is a very important and common thought process used to solve the questions of definite integral of greatest integer function. And even I will say that to solve this kind of question, if it is a linear function, first how you will start the question is you will substitute that linear function as t and then you start the question. So the question will just become greatest integer of t in terms of t. So this question will become similar to this one and you can easily solve. So this is the thought process you should always keep in mind to evaluate the integration of a greatest integer linear function. So now to evaluate this integral, what I will do is I will use the property of greatest integer. I can write it as x minus fractional part of x, which we already know we can write greatest integer in terms of fractional part like this. So now what I will do is I will break it into two parts. I will separate x and fractional part x. I will make two separate integrals. And now this integral value we already know, this is 2023 multiplied by half. Now we will evaluate this other value. So this value we will evaluate. X square by 2 will be the integration. 0 to 2023, if you will apply the limit, upper limit is 2023. And if you will evaluate x square by 2 and apply the upper limit 2023, so the value will come out to be 2023 whole square by 2. And lower limit is 0, so that value will come out to be 0. So this will be the particular value. And this value we have already evaluated like this. So this will be the value. From these two, you can see 2023 by 2 is common. So we'll take it outside. It will become 2023 minus 1. So now we'll put these two values and we will find the ratio. If you have to find this ratio, we will divide these two values and you can already see these two values. When you will divide, this value will cancel out with this value. So what will remain is 2023 minus 1, which is nothing but 2022, and that is the answer of the question given. So this is the answer, but let me generalize this expression which can be used like this. If the integration is from 0 to n is a natural number, greatest integer x upon fractional part x, we can generalize the result as n minus 1, as we can see from this expression, because here the answer will come out to be n minus 1 by 2, and here the division will be n by 2. N by 2 will cancel and all will remain is n minus 1. And we can generalize it if the lower limit is not 0, if the lower limit is a and upper limit is b. But b minus is a natural number, so the difference of lower and upper limit, that natural number value will come and you will subtract it with 1. So that will be the result you can easily remember and you can use it. Thank you so much for watching this video, and don't forget to like the video and subscribe to the channel to get updates on the new videos.